Let's say that you're going to turn A into B. And in the beginning of the reaction, you have a bunch of A's in the beaker. Okay? How would you like to be able to tell the future? How would you like to be able to tell how much B's you will have, how many B's you will have, and how many A's you will have left over? Okay? In this lesson, you will be able to know how much A's and B's you will have when the reaction is all done, when you have reached equilibrium. To do this, we will tabulate it, we will use the coefficients to do an icebox, and we will use Kc to find the final concentrations. Okay, so here's the sample problem. So it says that you have this equation H2 plus I2 becomes 2HI. Okay, it says you have a 1 liter flask filled with 1 mole of H2 and 2 moles of I2. So you have 1 mole of H2 divided by 1 liter, that's 1 molar of H2, so that's 1.000. And we're going to use molarity here. You can also use moles in the icebox, but in this case we're going to use molarity. For I2, you have 2 moles of I2 in 1 liter, so it'll be 2 molar. 2 moles for every liter is 2.00 molar. Okay, so that's what you put in your flask. And you didn't put any HI. So as you can tell, you put these together, it's going to turn into HI. The value of the equilibrium constant for Kc is given here, 50.5. So they gave you the equilibrium constant. So what that means is when the reaction is done, the ratio of products to reactants is 50.5 to 1. So that ratio is enough for us to figure out how much you will have in the end. Okay, so these numbers right here is what you have initially. So that's initial, and that is the I for, it starts with an I. Okay, and then the C is the change. Okay, so how much will you use, how much will you make of the products? And then the E is at equilibrium, when the reaction is all done or in the end. Okay, so the question is, what are the equilibrium concentrations of H? So what is this number, and this number when the reaction is all done? What is the ratio of products to reactants? What's the actual amounts? So the change will be what you use. There's a 1 right here, so therefore you will use minus 1 mole of X. There's a 1 here, you're going to use minus 1 mole of whatever that X is. And then over here, you're going to make 2 of whatever that value is, plus 2X. Okay, so in the end, you're going to have 1 minus X. Let me erase these numbers. I'm going to take away the significant figures for now just to make it simple. You're going to have initial minus with a change, 1 minus X, 2 minus X. And here you will have 2X. Okay, because that's 0 plus 2X is what you'll make. So the equilibrium constant is this, which is equal to HI squared over H2 times I2. K equilibrium is 50.5, you plug it in, equals HI is 2X. It's right here at equilibrium. That's how much you have. It's a squared because there's a coefficient of 2 in the equation right here, divided by H2 is 1 minus X, and I2 is 1 minus X, as 2 minus X. Okay, so all you have to do now is use this equation here, solve for X, and then plug it back in here as the X, and then you will know exactly how much you used of each, how much will be left over, and how much you will make in the end over here. Okay, so to solve for X, let's just you can use the quadratic equation. You can plug it into your calculator if you have the formula in there, but I'm just going to go ahead and walk through the problem solving here. So I'm going to just multiply these together. 50.5 times 1 minus x times 2 minus x equals 2x squared. So the most common problem here is they would forget to square the 2. So they would just say 2x squared, but it's really, when you square this, it's going to be 2 squared, which is 4, and then x squared. So don't forget that. Okay. And then this one I will just 50.5. I'm going to FOIL this first 2, and then I'm going to do outside and inside. So minus x. The outside would be minus x, and then inside would be minus 2x. No, this is, inside would be, outside would be minus x, inside would be minus 2x. Okay, so minus x and then minus 2x is minus 3x. I'm just going to do that in one step. Minus 3x, and then the last would be minus x times minus x would be plus x squared. Okay, then just distributing this out, 50.5 times 2 is 101. This times this is negative 151.5. And then this times this would be 50.5x squared. Equals 4x squared. Okay, I'm going to go ahead and move this over here, set it equal to 0. So it'll be 50.5 minus 4x would be 46.5 x squared. Okay, so I just did this. I combined this and this. Then I'm just going to rewrite this one, negative 151.5x, and then write this one, plus 101. Okay, so using the quadratic equation, this would be the a term, this would be b, and this would be the c term. Okay, so now the formula is x equals negative b plus and or minus the square root b squared minus 4ac all over 2a. Okay, again, you can use your graphing calculator if you need to plug it in there. So you plug in the numbers. B would be negative 151.5 plus or minus 151.5 squared, b squared, minus 4 times a is 46.5. Times c is 101. Take the square root of that whole thing, all over 2 times 46.5. Okay, so when solving for x, I got 2.3 and 0.935. Okay, so only one of these will be true. If you think that x is 2.3, what is 1 minus 2.3? It's a negative number. Therefore, it can't be 2.3. You can't have a negative molarity. So it would have to be 0.935. Okay? So at equilibrium, when the reaction is all done, you used to have 1 molar. You're going to use 0.935 of it. So 1 minus 0.935 is how much H2 you'll have left over. Okay? And then whatever that number is, you just plug it in there. And then for I2, you have 2.000 minus 0.935 will tell you how much I2 you'll have left unreacted. And then 2 times 0.935 is how much HI you will make in the end. So let's go ahead and plug that in the calculator. So I got, in the end, the final answer would be 0.065 molar of H2, 1.065 molar of I2, and 1.87 molar of the product of HI. This is how much you'll make in the end, and these two are how much of the reactants you'll have left over.